Hopefully by now you've actually read through the slides and understood most of them. If you guys have questions as you're going along, make sure that you email me with those. I will go ahead and answer your questions if there's anything that you're not understanding. What I'm going to do is I'm going to record a series of 4 audio recordings that are on topics that I think are very pertinent to this chapter that you probably wouldn't pull out of the chapter by either reading your book or just quickly running through the slides. So the first one I'm going to want to talk about is the relationship between calcium, magnesium, and osteoporosis. The media is very good at promoting the fact that you need to drink milk because it makes your bones strong, and we all know that the reason why that's supposed to be is because of the calcium that's in milk. But the problem is that a lot of that, the reason for promoting the milk and the calcium and the strong bones is because we're seeing a lot of osteoporosis in our country. And it's interesting to note that despite the fact that for generations now, most Americans anyways, have drank a lot of milk, and yet we're still seeing osteoporosis again and again and again. So the question we have to ask is why? Obviously, just simply drinking milk is not doing the trick. And hopefully after this recording, you guys will understand why it is that dairy doesn't necessarily provide you with the calcium that you do need, at least not enough to prevent you from getting osteoporosis. Before I talk about that, though, there's one thing that I really quickly want to remind you guys of as you're reading through these slides, and you see that one of the functions of calcium is to balance out the acid and base. This is not something that is new to you. However, you might just need to be reminded of it. In several lectures ago, we had talked about the fact that meat and dairy and some other foods, sodas, produce in your body a very acidic ash. And if your diet is very balanced, then traditionally what should happen is you would be eating a lot of green vegetables, and the green vegetables would come alongside the meat and the dairy, and it would buffer that acid out of your body. However, most Americans nowadays don't eat a lot of green vegetables, but they do eat a lot of the meat and the dairy and the sodas. So what ends up happening is we have this huge buildup of acid in the body, and the body doesn't function in very acidic conditions. And so instead, it's going to start pulling calcium from the bone, dumping it into the blood, and the calcium is going to work to buffer out all that excess acid. When we had talked about this, we discussed it in the realms of eating a lot of meat or a lot of protein and how ultimately it can lead to osteoporosis. And that's the reason why. So I just wanted to remind you guys of that. So going on then to the relationship of calcium, magnesium, vitamin D, and osteoporosis. If we go a couple slides over, this is going to be key in this whole picture. The calcium-magnesium ratio has to be 2 to 1 in order for calcium to absorb properly. So I'm going to flip over to this screen. What ends up happening is that a lot of dairy sources do contain a lot of calcium. In fact, in one serving of dairy, which is about 8 ounces of milk, you get close to 1,200 milligrams of calcium. That's well above what's needed for the average adult per day. So theoretically, you should be able to get all your calcium by simply drinking 8 ounces of milk. The problem is that the magnesium in dairy is very low. At maximum, you might get 20 milligrams of magnesium in dairy. So if you remember, the ratio again between calcium and magnesium has to be 2 to 1. So if by chance you are getting 20 milligrams of magnesium in one serving of dairy, that means that at most you would only absorb 40 milligrams of calcium, not the full 1,200. The rest of it is simply going to get excreted. And that's why you can drink a lot of milk and still not get the calcium that you need. One student had asked me how many glasses of milk would it take to actually get up to 1,200 milligrams of magnesium and actually absorb it all. And the answer would be about 25 cups of milk before you'd get that full amount of calcium. And nobody drinks that. Okay, so what I want to do is I want to show you what this looks like. In order for this to absorb, you need 2 calcium molecules. And this is going to look kind of strange because it's not easy to draw on this board. And then connected to the 2 calcium molecules is or the 2 calcium atoms is a magnesium atom. So there's the full molecule that will get absorbed. And let's switch out colors. Let's say this is the cell membrane. between your small intestine and your blood supply. Sitting in that cell membrane, you have a protein, and remember, the proteins are shaped according to the molecule that they want to transport in. So this is kind of what our molecule looks like. So the goal is to get this molecule, or this group of calcium magnesium, through the small intestine into the blood, and it happens with this receptor. This receptor, by the way, is vitamin D. So this is the link now. You can even consume adequate amounts of calcium and magnesium and still not be able to get it through if you don't have adequate vitamin D. Now, one thing I forgot to mention, if you go back up here, the veggie sources. Interestingly enough, most vegetables, especially carrots, broccoli, and kale, have about 40 milligrams of calcium in them and 20 milligrams of magnesium. So you get that perfect 2-to-1 ratio. Sometimes it's even a 1-to-1 ratio. So it's interesting to note that you get just as much calcium from eating carrots as you do from drinking a glass of milk when it's all said and done and it's all absorbed properly. Okay, so now that you can see the link between calcium, magnesium, and vitamin D, the other thing that I need to mention is that milk is often fortified with vitamin D for the purpose of being able to bring in the calcium and the magnesium. The problem is that in a lot of your milk, you have a synthetic form that's called vitamin D2. And D2 is very easy to make in a lab. It's very cheap to make in the lab. The problem is that it's not very bioactive. That means it doesn't absorb very well. So this form actually is not very active and it doesn't work. So even if milk is fortified with vitamin D2, you're still not going to be getting in the calcium and the magnesium, and you already have a small amount of calcium that actually would be going in. So hopefully you're starting to see the picture now of why it is that you can drink milk and not really get your calcium. It's first lacking magnesium, but then it's lacking the right kind of D also. What you really want to see in is vitamin D3. D3 is an active form. It works as this receptor. And I think more milk suppliers are starting to add D3, probably because they're realizing now that we're still lacking in vitamin D. But not all of them do. So check your food label and check to see if your milk has D3 or D2 if you still drink milk, because that is a very important element. So what I want you to pull away from this whole thing is that the reason why we're still promoting a lot of heavy milk consumption is because of the large amount of calcium. But again, remember, the calcium, even though it's a very high amount, you're not absorbing it because there's no magnesium in milk. There's some, but not a lot. So you're not really absorbing any more calcium in milk as what you really get in vegetables. The 40 is the same as the 40 up there. Okay, so problem number 1, not enough magnesium. Problem number 2, down here, not enough D, or not the right kind of D. So as a result, we're not getting the calcium we need, and then you end up with osteoporosis.